Y'all, it's the sections get pretty fast right now. It actually ends up being my favorite chapter of this class. Is that right? Yes, that's right. Okay. This chapter, I think I've always liked it because it's like a big old puzzle. Exponents. So it'll be just kind of like evaluating exponents. And then there's like all these different rules. So you have rules. So, okay, it's similar to just an example. Okay, say we have like 7x times 2x. You do 7 times 2, that'd be 14. But the rules they introduce now is whenever you look at your variables, they would be called bases. So it'd be x times x. What you do is you keep your x and you add your powers. So x times x becomes x squared. And that's mainly what it's all based around. Multiplying different bases, dividing them, and then a whole bunch of rules. Like I think this is the most amount of notes I've ever had in this class, like for a day. You know what I mean? I didn't actually solve the last one thoroughly. I just wrote the problem and then the answer because I don't see us getting to it. But all of chapter 12.1, I already have the videos done and uploaded on YouTube. 12.2, because I'm off on tomorrow. I'm supposed to have one of my friends enroll in college, which I'm super excited about because that's awesome. So maybe like that afternoon or evening, I would go ahead and I'd want to record all of 12.2. You know what I mean? If I can start even 12.3. We'll do 12.1 and 12.2 today. I don't like this room. And then on Friday, we do 12.3 and 12.4. Then on Monday, 12.5. And then on Wednesday, 12.6 and 12. I think the other ones are kind of spaced out and given a whole day. But like 12.1 and 12.2 are similar. I haven't looked at 3 and 4, but I would assume, Yeah, I just don't know. I know, okay, so we have certain rules here. I just don't remember off the top of my head like what the title is or like, you know what I mean? Like specifically what the problems will be. And then I still want to try to do 2 days review. I know we did on exam 1. We didn't have time for exam 2, but for sure with exam 3, for these problems, we need 2 days to review. So even if I just kind of get through the material, right, you have the videos that would go slower that you can pause. But then having the 2 days to review, like I think that would really help. On my YouTube page, I've sent a couple of emails, I think. I just don't know like the last date I sent it. I could probably go ahead and send a new one, you know, so it's like up top of your emails and not down below. Yes, everything that I send in this class has to go through that Paris Junior College portal. So when I click like email class, it goes to that Dragon email. So if I ever send an important email, it goes there. So like I would check that. It's activated, right? Do you already have it activated? No? Okay, so write your Leo Mail email on a piece of paper before you leave. Just give it to me so I have it. I'll send you an email that tells you how to activate your Dragon email, and I'll even give you your Dragon email. You know what I mean? I'll give you all of that. So you go to their website, you activate it. Once you activate it, you'll have emails from me. The most recent ones, like start there and read those. The other ones might, like they've already passed, you know what I mean? But I know that within the last week or two, I've sent a couple of important ones. Last night, did I send that one last night? Is going to be the most important one that I sent. Okay. You know, my back hurts. Okay. So it's 1 o'clock. We're going to go and get started. I think I need to invest in some better pens or markers or whatever. The ones I like are dying. I just want to make sure that it's kind of clear what I'm doing. I'm just going to grab a couple. I like the black ones. We're going to start 12.1. we're going to do 12.1 and 12.2. We're not just going to start 12.1. We're going to actually do 12.1 and 12.2. This is now a new chapter. So all of chapter 12 is what we're going to be tested on for exam 3. These first two sections, oh, my ear always needs to pop. The first two sections that we do, what we're dealing with is exponent rules. Y'all still see that? I'm going to switch y'all over real quick. So, okay, exit full screen. And let me switch y'all with this. I think if y'all have that view, like it doesn't look as clear. Hopefully this will be better. I don't think we do this in this class. Okay, so let's get started. Like I said, this is going to be a lot. I've got 4 pages, and it's different. Okay, so be ready to ride. So for 12.1, what we're going to start with is using exponents. Technically, 12.1 is going to be exponent rules, but I'm going to write like exponents. We'll do a few problems. Then we're going to look at a product rule. I'll show you the rule. We'll do a few problems. Then a power rule. You know, I'm going to kind of break it down like that. So, I mean, if you wanted to go ahead and call 12.1, we could say exponent rules. It just might not be the exact word that they use in the book, y'all, okay? I don't like this marker already. Okay, so the first thing we're going to learn is about our exponents. The way you'll see this written is, say we have the number A. I know I said number. I meant to say number because it can be a number. It can also be a variable, but if I say a number A, it just means it can also be a number, right? Say it's being raised, oh, I like this one. It's being raised to a power. We've seen this before, right? Like 2 squared, 3 cubed, 4 to the 5th power, right? Doesn't matter. It's just something being raised to a power. This is our base. That's what that is called, is our base. Our n right here is going to be our exponent. Exponent. What it means to be written like this, in the homework, if you see something that says leave it in exponential form, that means leave it in the form where you have a base and you have an exponent. Where you have a base and you have an exponent. What it's also saying is what you do is you take your base, whatever it may be, and you're raising it to that n. You're raising it to, it's like a power, right? And what it means is you're going to multiply your base to itself however many times your exponent says, okay? And this will be a better example, is just to actually do this one right here. Let's do this first example. Say we have 2 raised to the 5th power. It is like a little subscript. Okay? It's a little bitty 5 written up top. This does not mean 2 times 5. It is not 10. This is literally saying 2 times 2 times 2 times 2, right? It's the base multiplied to itself this many times. You can use parentheses. You're going to want to when it's a negative sign. Right here, because you know there is no negative signs, you can just write 2 times 2 times 2 times 2 times 2. Y'all, honestly, your calculator should be able to evaluate that for you, okay? And you'll get the correct answer if you enter it in correctly, especially if there's negatives. If we look at this, y'all, 2 times 2 is 4, 4 times 2 is 8, 8 times 2, 2 times 2 is 4. Did I write it? 1, 2, 3, 4, 5. Yeah. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 would be 34, 32. So that would be your answer. This is evaluating this 2 raised to the 5th power, okay? So there's 2 other ones I want to show you because this is definitely how in the homework it could be confusing and as well on an exam. If they have a -2 and it's in parentheses, and then say it's being raised to the 4th power, because it's in parentheses, this is telling you that negative is a part of that too. So this whole thing right here, that's your base, okay? That's telling me take that whole thing and multiply it to itself that many times, 4 times. So this is where you would want to use parentheses, okay? In your calculator, you should have a parenthesis button. You would actually want to put it in parentheses. So let's go ahead and look at this because the next example is going to show you why this is so important. I'm actually writing -2 in parentheses next to itself 4 times because that, everything just touching, right, that implies multiplication. So y'all, I'm just going to do the numbers first and then we'll look at the signs so we can see the differences here. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, right? Now let's look at our signs. If you did negative times a negative, you get a positive, right? Those signs are the same, so it's positive. Now use this sign here. If you do positive times this negative, you get a negative. Now do negative times a negative. What do I get back to? I get back to a positive. So my answer is a positive 16, okay? I'm showing it to you like this because I really want you to see how the homework will try to confuse you. Go ahead and write -2 to the 4th again, but don't use parentheses. Just do -2 to the 4th power. Literally all parentheses can make or break an answer, okay? Your base here is just what's being raised to the exponent. Here in parentheses, I had a negative and a 2. Here with no parentheses, just my 2 is my base. That negative's there, right? It's an addition to this 2 raised to the 4th power. But the only thing I'm going to multiply to itself 4 times is 2 times 2 times 2 times 2. We can go ahead and use parentheses here for continuity. That negative sign, I just put it right out here in the front. If you wanted to make it a -1, you can. But just know, because it's not in parentheses, it's not a part of what's being multiplied over and over again. Okay? Y'all, 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. But we had that negative sign, right? That negative gets tacked onto that 16. Do you see how these look similar? But because of those parentheses, my answers, they have different signs. Okay, so if you have this, but you put it in your calculator like this, the rest of your problem's probably doomed. Okay, and a lot of math problems from the get-go, they have to be done correctly, or you just kind of, it falls apart, right? If you have this, right, and it shows you that it's in parentheses, and you don't put it in parentheses, again, your sign ends up being wrong, okay? So that's just kind of how to use exponents and how to answer the first few problems that you'll see on your homework, okay? Let's go ahead and move on to, we're gonna look at product rules and power rules, okay? Oh, that's my marker. I forgot which one it was. We're gonna start with product rule. If I can spell product rule. Now, you know how like if I add things together, that's called a sum, right? If I have two things that I subtract something, that would be like their difference. And if I divide something, that answer is called a quotient. The product rule comes from multiplying things, okay? That's what it means. When you're multiplying these specific things, this is the rule you use, okay? I just want y'all to ask questions if you need to after class, email, videos, whatever you have to do, because it can get very confusing. The rules themselves are real abstract. You just have letters and they're arranged a certain way. You're supposed to see the connection between this is how it started and this is what it can be turned into, okay? So this is the product rule. The product rule states that if you have something, some number, some variable, it's just something. I'm going to use A's for all these rules, okay? If you have something being raised to a power, let's say that power is M, and you multiply it. You just use a dot here, y'all. Don't use an X. They'll throw everything off, okay? A little dot. and you multiply it to the same something, the same base, and it's also being raised to a power, but you're going to do n here, not m. What this is saying is I'm not just going to say it's two things. You can have 5, 6, 7 things. This homework can get crazy, okay? But I have the same bases multiplying each other, and they have exponents. This is just saying that they can be the same, they can be different, it doesn't matter, but they both have exponents. If these are both m's, that's me telling you it has to be the same exponent, and that's not true, okay? It could be whatever, and I'm going to do examples. Hopefully it makes more sense. So if we have the same bases multiplying each other, and they're being raised to some kind of exponents, right? So some kind of power, what you do is you keep your base and you add the powers. That's why the bases have to be the same. In this general little formula, do you notice how those are both A's? They have to be the same, whether they're the number 2, the number 14, or the variable Z. If they're the same, you can apply this rule, okay? So let's actually do some examples. I start first with just some actual numbers, like numerical values. Some people might understand it better with the variables. We're going to do an example of both. Do you agree with me? This is what we just learned, right? This is a base. That's an exponent. So that's a base. That's the exponent. That's a base. That's an exponent. Do you agree that all of those are the same base? Okay. It doesn't matter that there's 3. The same rule is going to apply. If you have the same bases multiplying each other, what you do is you keep the base and you add the powers. What's my base here? 3. Keep the base. And then I'm actually going to write out, y'all, 4 plus 7 plus 3, because we're adding them. That's what the rule told me to do. 4 plus 7 plus 3. I feel like there's something in my nose. It's tickling me. So whenever I actually evaluate this, that's really the only math now that I do, right? 4 plus 7, that's 11, plus 3 is going to be 14. So this is 3 raised to the 14th power. I kind of didn't really look at the homework very thoroughly, but it might want you to evaluate. If it's 3 squared, it's going to want you to enter 9, right? But if it's 3 to the 14th, it doesn't want you to use your calculator and figure out that big number because it's huge. So there might be a number, like you evaluate it if it's 4 and under, you know what I mean? But if it's higher than that, you leave it in this form. You leave it like that. That makes sense? Same basis. You just keep and add. When you multiply, you keep and add. Okay, so let's do this example. This is very similar to the first one, y'all, but instead of numbers for my bases, I'm going to use variables. Okay, say we have x cubed. Cubed means to the 3rd power, right? X cubed times x to the 6th times x to the 13th. Excuse me. Are all of those the same base? Yeah, and what's happening here? If they're all in parentheses, they're multiplying. If they're all touching, they're multiplying. If you see a little dot, they're multiplying. It's all multiplication, right? I don't see a plus sign or a negative sign. So it should be very clear this is multiplication. So what I would do is the product rule, because the answer to a multiplication problem is the product. And so what I'm going to do is apply it. The rule said keep the base, and we're going to add the powers. That's an equal sign, y'all. It's just kind of not right. Okay, 3 plus 6 is 9. 9 plus 13 is 22. So my answer is x to the 22nd power. Okay. I'm going to do an example that kind of stood out to me on the homework just because when y'all see it, I just want you to know how you can go about solving it. There's multiple ways to solve all of these problems. They're just big puzzles, honestly. As long as you don't break any of the rules, then you're okay. So this example in parentheses, we have a negative 2x to the 9th. Close your parentheses. Open up some more and do 6x squared and close. Do you agree? That's multiplication, right? I'm doing the first set of parentheses, whatever's inside of it, multiplied to the second set of parentheses. Are these the same bases? No. So this isn't the keep and add rule, right? But because it's multiplying, I actually can multiply. -2 times 6, right? Those are just coefficients. I can just do multiplication. -2 times 6 is what? 12 signs are different, so it's negative. So that's looking at the coefficients. Now, as far as my bases, these would be my bases. All you really need to do after a while is what I've always done is like 2 times 6 is 12. Signs are different, so it's negative. They both have x's in common, right? I know that when I multiply my variables, I keep and I add. So -12 x to the 11th is the answer to that problem. They just kind of put it in this way. I don't know, just I felt like maybe that one would be bothersome. Okay, y'all. So what we're going to do now is there are 3 power rules. We're going to look at the first one. Okay. So this power rule, this is what it is. Open up a set of parentheses. Inside of it, do a raised to the m power. It's supposed to be imp, but imp is really hard to say. A raised to the m, close your parentheses. We're going to raise it again to the nth power, m and n. So that's literally going to be a base, whatever it may be. It's raised to a power already. So if we're going to raise something that's already being raised, you have to put it in parentheses, okay? So what I've always called this rule is power to a power, right? We've got something raised to a power, raised to another power. Power to a power, multiply your powers. What you do is you keep your base and then multiply. M times n. Power to a power, multiply your powers. Okay, I've got 2 examples for this rule. I do one just numerical values, and I'm doing one with exponents. So parenthesis 3 squared close. And then all of this raised to the 3rd power. On your own notes, I would be careful with this, and on your like exams and stuff, I'd be careful with this. Make sure that when something does have a power, it's very clear that you wrote it smaller and kind of higher. Do you see what I'm saying? If you don't do certain steps to problems, it'll look a certain way, and then maybe it could cause you to go down a rabbit hole, and then your answer is not correct. But if you're very intentional by doing a large base and a little power, you know for a fact that's not 32. You know what I mean? So, and especially now we got 2 powers. This is not 323, it's 3, 2, 3, okay? So that's a power to a power. My rule says multiply your powers. So you keep your base. What's my base? 3? So keep your base. Then we're gonna multiply. Y'all, when I do this, I always put that second number in parentheses because I know that means multiplication. If you did a little dot there, that's still okay. As long as you know they're multiplying and you don't accidentally add them, because that's another rule, right? And that wouldn't be applied here. So I keep my base. What's 2 times 3? 6. That makes sense? Had a little power, and then it was raised to another power. Power to a power, multiply your powers. Now let's do this example. Say we have in parentheses x squared close. Now raise it to the 7th. As long, y'all, as long as you don't make this one x to the 23rd power and you don't make this one x to the 27th power, I can't really think of any other way that you could mess it up except for maybe trying to add them. So you've just got to keep the rules separate. Here's power to a power. It doesn't become x to the 27th power. That's not right. It would be keep your base multiply your powers. What do I have? X to the what? Power to a power, multiply your powers. Okay, so that's one of the power rules. Let's look at another one. Okay, so another power rule. It's very similar to that rule. Open up parentheses, and we're going to do A times B. So normal size is A, B. Close your parenthesis and raise it to the nth power. And I just want to make this clear. With all of the rules, I just want you to understand the rule being like a formula or something that you know you can always use. It's as simple as it can be, right? If you are going to do a problem, which believe me, there's a sum. I was going to say a lot, and then I was going to say some. It came out of some. This might look to some people like if I have two different things, I do this rule, right? But you could have A, B, C, D, E. You could have a number of things. This rule is just letting you know, I'm going to show you, but this is what you do if it's in like this format, okay? This is just saying that we've got different things. Doesn't have to be two different things. It's just different things going on inside of parentheses, all being raised to a power. What you do is everything inside of the parentheses gets raised to that power. I'm going to write this one little asterisk note here. I don't know for sure if it does this in the homework, but I really want to make sure that y'all don't ever confuse it with this, especially moving forward. We're about to divide polynomials, multiply polynomials, learn all these different special techniques and stuff. And I don't want you to think that this rule applies to this example. So this is in red, y'all. If you have A plus B close raised to the m, question, what are these terms, however many there may be, what are these terms doing inside of here? They're touching. There's not a sign. So what's happening here? Yeah, it's A times B. It could be A times X, or actually it could be like 2 times X squared times Z to the fourth, whatever. It's all multiplication, right? What's happening here? That's addition. Yeah, we're adding them. That's a sum, okay? You cannot simply do something that's similar to this, This power rule, right, is only going to apply if everything inside is all just being multiplied, okay? If you've got operations, so a coefficient could be negative out front because it's not really being subtracted from anything, right? But if you ever had a sum, you can't use this rule. That should probably just kind of pop up later. I wanted to say it now though, so no one's like, you didn't tell us that. Okay, so I put it on red. It's my little side note. Now let's do this example. Say in parentheses, I have 2x close, raise it all to the third power. That is this rule. I've got two different terms in there. They're multiplying each other. They're both inside of parentheses being raised to a power. So what I can do is raise each individual term to that power. So I can raise 2 to that power. Even though it's a coefficient, even though it's a number, it's a part of those parentheses. It's going to get raised to that power. And then my other term, my other base, technically, right, that would be a base, this would be a base, is x. It's also going to get raised to the third power. Just because I don't know when it wants you to evaluate it, 2 is 4, 2 is 8. This would actually be completely evaluated by doing 2 cubed equals 8, okay? That makes sense. 2 cubed, 2 times 2 times 2, you get 8. That you can't do anything there. It's just x cubed. Okay, I'm gonna do one more example here. 7x, y, z, close and square everything. So as far as that 2, that squared term, because it's on the outside of the parentheses, I actually have 4, right? I have 4 different things inside of the parentheses. I've got a 7, I've got an X, I got a Y, and I got a Z, right? Do you agree with me? None of those are the same. That's just a number. That's an X. That's not an X. That's a Y. That's not a Y. That's Z. Do you see what I'm saying? They're all different. Because they're inside of the parenthesis being raised to a power, each individual one is going to get raised to that power. So 7 squared, X squared, Y squared, Z squared. Y'all, we know what 7 squared is, though, right? 7 times 7 would be 49. I'm pretty sure that might be what they want you to do in the homework. Not for all of them, but when it's, 2, you can. When your exponent's 2, you can evaluate it. Okay, that makes sense? There was all multiplication going on inside of there. That's why I could do that. Oh, y'all, I'm gonna have to go real fast. Okay, so let's do this other power rule. There was 3. This is the third one. Do kind of a large parenthesis because it's going to be written as a fraction. I've got A in the numerator. I've got B in the denominator. Close it. It's all being raised to the M. So kind of looking at the previous rule, it's like, okay, A is going to get raised to M. B is going to get raised to M, right? Doesn't matter if it's in a fraction form. We're going to raise whatever is in the numerator because there could be A, B, C, D, right? Whatever is in the numerator is going to get raised to that M power, and whatever's in the denominator is going to get raised to that M power. Y'all, I just did one kind of example with variable here, X over Y raised to the 4th. So this rule, whatever's in the numerator gets raised to the power, whatever's in the denominator gets raised to the power, right? What do I get? X to the 4th, Y to the 4th. Does that make sense? Okay. So I actually have some pretty long, not really complicated, but more difficult examples on the YouTube page, okay? And it will literally say PJC 12.1, da 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 da. I would recommend watching those because I can't cover everything in here. We are actually going to combine these rules real quick. I'm a little behind where I wanted to be, but I think this is a very important example because it's literally pulled from your homework, okay? So I just wrote combine. We're going to combine all these different rules. Not every single one, but you'll notice it's a lot, okay? So say if in parentheses, I have 5b raised to the 4th power, and then c raised to the 3rd power, and then d. Now close, and now raise all of that to the 3rd power. Oh, wait, just wait. Open another set of parentheses. B, C to the 4th, D to the 4th, close, cube it, meaning raise it to the 3rd power. So do y'all see how already it looks like that rule where I had A, B, and then what I did was they each got the power? What we're going to apply that, and then you're going to notice, oh, this is another rule. And then towards the end, you're going to notice, okay, all of these are multiplying, and I've got a lot of B's and I got a lot of C's. Oh, that's the product rule. That's where you keep and you add. So it involves all the rules. The only one it didn't involve is just the one where it's written as a fraction, which I have examples of that on the homework as well, okay? So that first set of parentheses, I have different terms. There's no like plus sign, okay? There's no plus sign in here. I know everything can get this exponent, which is 3. So literally, y'all, don't leave out that coefficient. Don't leave out that 5. In all of my classes, this is the main thing that gets left out, okay? It's still a term inside of these parentheses. So it also gets raised to this power. So I'm literally going to raise everything to this power. 5 cubed. The b to the 4th, don't just write right now b to the 4th and then try to do it as cubed in your brain. It's going to look like 43, right? So what you want to do, because it is something that already has a power, put it in parentheses. b to the fourth, that's in parentheses, being now again cubed. And now do your parenthesis c cubed, close, cube it again. Is my d being raised to a power right now? I mean, technically it's a 1, but there's not anything else, not a 2 or 3 or 4. So this one, you could just go ahead and do d cubed. If you wanted to do parentheses, you can. Just when you write it the other time, you'll notice it's just d cubed. So now let's look at the other parenthesis. Do you agree? All multiplication, everything can get raised to this power. So b, that doesn't have an exponent on it. I'm just going to write b cubed. C to the fourth is being raised to a power. I'm putting that in parentheses, and then I'm raising it again to the third. And then parenthesis, d to the fourth, close parenthesis, raise it to the third. So now we're going to look individually at all of these. Y'all, just to save time, I'm not going to evaluate 5 cubed. I'm just going to leave it 5 cubed. If you have your calculator and you do it, it's perfectly fine and it's correct. I'm just not going to do it. So I'm going to just continue working left to right. I've got 5 cubed. Now right here, isn't that like the first, I think, power rule? Power to a power? Power to a power, keep your base, multiply your powers. Power to a power, multiply your powers. My base is b. Keep your base, multiply your powers. I get b12, right? Now scoot over. C cubed, cubed, power to a power, multiply your powers. I get c to the 9th. That d cubed, that's just d cubed, right? That b cubed, that's just b cubed. C to the 4th cubed, power to a power. Keep your base, multiply your powers. D to the 4th, and then cubed, power to a power, multiply your powers. You keep your base, that's my d, multiply 4 times 3, I get 12. This is what I meant, right? So we applied that one rule where everything gets a power. Then we applied that rule where we had power to a power. Now we're going to apply the rule of the product rule where things are multiplying, because that wouldn't be the correct answer. Wouldn't I only have like 1b? And I only have like, I'd only have written b one time. Whatever the exponent may be, I only need to have written b one time. I've got 2 of them. I've got 2 c's. I got 2 d's. So you basically are going to combine them, making sure you use the exponent rule. Oh yeah, making sure you use the exponent rule, which is called the product rule. Okay, so we have 5 cubed, right? Now if I look, I mean, they go in order, y'all, right? X, Y, Z, B, C, D. So I'm going to start with B. Do you see how I got a B to the 12th and I got a B cubed? Those are multiplying. All of these are multiplying. And that product rule said what? Keep and add. What's 12 plus 3? 15? And then I did my little thing up top right here. I got a C to the 9th, a C to the 12th, all multiplying. Keep and add. C21. And then I got a D cubed and a D to the 12th. Keep 12, 13, 14, 15, add. Now, if you wanted to, right here, y'all, once you got to here and you notice you got a B, C, D, B, C, D, you can rewrite it again. Do 5 cubed, B to the 12th, B cubed, C to the 9th, C 12th. See, do you see what I'm saying? Write all the B's together, write all the C's together, write all the D's together. Then you'll actually see, hey, those are multiplying. Keep and add. Okay, here I just kind of picked them out of the group. You have to make sure you don't leave any out. Okay. Okay, so those are the product rules and the power rules, and that's actually combining all of the rules we just now learned. Okay. So, is this 4.2? Okay, now it's 4.2. I really needed to get through all of this, but I'm just hoping that we can. 12.2, we're going to look at, it's just more exponent rules, and I'm going to break them down, okay? The first one we're going to do is a 0 exponent rule. I don't like any of my markers, they all suck. Try blue. Okay, 0 exponent rule literally tells me that my exponent is 0. So if you have a problem and the exponent is 0, you would use this rule. Just like with the other ones, you're kind of looking at a certain form. Oh, hey, this matches that form exactly. Use that rule, right? The zero exponent rule, I'm just switching colors because, yeah. Say we have something, I wrote A because it's just the rule. We have something raised to the zero exponent. Anything raised, any base raised to the zero exponent will always equal 1. There's maybe 2 little kind of confusing parts that I've always noticed with this rule as well. Let me go ahead and do my examples. If we have 5, say 5 is my base, and we have 5 raised to the 0 power, what does that equal? 1, because I just have a base raised to the 0, I get 1. Now let's do this example. Say if inside of parentheses, I have negative 17 close parentheses, raise it to the 0. With that 5 raised to the 0, that was my base, right? That whole base, it went to 1. Raised to the 0, it went to 1. This is a whole base. Raised to the 0, it goes to 1. Okay? This is really similar to the exponent, like with the negatives and stuff. So I want to show you these. I always see y'all's eyes moving. I wonder who is that? I'm nosy. Okay, so now let's do an example where it's being raised to the 0 power, but what I have is negative 6 raised to the 0 power. This is what I want y'all to hopefully be able to notice. What is my base? 6. If it's in parentheses and there's a negative sign, they're putting it in parentheses to let you know that negative, it goes with that value. So it's all one base, right? This 6 is your base. That negatives just happens to be there. It's technically a negative 1 times 6 raised to the 0. Well, the 6 is going to go to 1 because it's being raised to 0, right? But because we had that negative sign not in parentheses, it makes it a negative 1. Does that make sense? Okay. Oh, and then there was one more. I kind of added this last second just because this is and always has been an exam problem. Okay. That's like when you do an asterisk. And it will look insane for a specific reason. Okay. I almost just want to make stuff up right now. Parenthesis 7x y to the 4th z to the 16th close. That's like a baby problem compared to what I would put on the exam. Okay, raise it to the 0 power. What does it equal? Because I got stuff in parentheses, and that whole set of parentheses is being raised to the 0 power. This is the perfect example to put on an exam to see, did they hear me when I was saying anything raised to the 0 power is going to be 1. The only thing that kind of throws that off is whenever you got that negative on the outside. That was being raised, it went to 1. Oh, there's that negative, right? This could have 8 different variables. I've seen people try to solve it and create new math, and you just can't do that, okay? That goes to 1. Okay, so that was the 0 exponent rule. Now we are going to look at a rule. I don't like using blue. I don't know why I pushed them. Now we're going to do a negative exponent rule. So that literally tells me whatever my exponent is, it's a negative 1. Not like the number 1, right? But it's a negative exponent. And here's the rule you apply when you see that. So a negative exponent, look how lazy I am. Neg exp rule. Negative exponent rule, okay? This is the rule. The rule is if you have something, it could be a 2, it could be a y, if you have something, right, raised to the mth power, but it's a negative m. So that's saying I have something at whatever base it may be, and it does have an exponent on it, and that exponent is a negative exponent. I'm going to tell you right now, I don't know if you want to asterisk this, but A correct answer will never have a negative exponent, okay? Especially in an exam. That's your main goal, is to make sure that you evaluate and you always get rid of, and you never have an answer that has a negative exponent, because it won't be the correct answer, okay? A correct answer will never have a negative exponent. This is what you do. If you see this, what you do is you actually are going to put A in the denominator. It's still being raised to M, but technically, I've always said like up top and down below, technically that can be written over 1, right? It never changes it to write something over 1. So it would be like up top. If it's up top with a negative exponent, you bring it to the bottom. It makes that exponent positive. I want to write this also. We're going to go ahead and say and. Say we have 1 over A to the negative M. If it's down below with a negative exponent, it would go where? Up top. And that makes it a positive exponent. So a negative exponent moving from top to bottom changes it from negative to positive. Okay? So this one, if it's in the denominator and it's negative, I can write it as, y'all, those technically are over 1. Okay? Just know if you see it like this, it's not in fraction form. You put it in fraction form down below. That makes that exponent sign change. If you see it like this and it's in a fractional form, you would bring it up, and that makes the sign of the exponent change. I want to know what's going on up there. Okay, so let's do an example of that. I'm running out of time. Okay. I gotta change papers. I'll write leave it. Okay, here's my first example, y'all. It is 3 raised to the negative 3 power. Is that in fractional form? No. So if it starts and it's not in fractional form and it has a negative exponent, I put it in fractional form, right? Which means I'm going to bring it down to the bottom. Now, the sign, right here, y'all, the sign on my exponent went from negative to a positive. You don't lose the exponent or anything. It's still the exact same exponent. It's still going to be the number 3. But now instead of it being a negative 3, it's a positive 3. And the homework, y'all, just so you know, they're probably going to actually have you evaluate this. 3 times 3 is 9. 9 times 3 is 27. Okay, the answer here would be like 1 over 27. Okay, just time-wise, like I haven't been evaluating every one. 5 cubed, they'd have you do that one too. Okay, so let's do this one. Here we go. I think we need to do this one, and I need to make up another one. Okay, so this will be the one I make up. Say we have 1 over 2 to the negative 4th power. Is that in fractional form? Fraction meaning like something divided by something, right? That's a fraction. This is in fractional form, right? But it's telling me to evaluate it. The only thing I could do is notice that that exponent is negative, and I don't ever want a negative exponent because it started in the bottom. It can be written up top. All that means is you take it from a fraction form to just like a whole number form. So instead of it being 1 over 2 to the negative 4th, it's just 2 to the positive 4th. And that's going to match that rule when we did the little ampersand, little and sign. 1 over, it was in fractional form. I wrote it in like a whole number form. What it does is it changes the sign on the exponent, right? Okay, so this is the one I have here because it is an example from your homework. Say if in parentheses, in fractional form, we have 1 over 9, close parentheses, and raise that to the negative 2 power. Remember that power rule? That last one we did, it was like A divided by B, and they were both in parentheses being raised to M. So what we did was we did A to the M, B to the M, right? You could go ahead and do that. You could go ahead and do 1 to the negative 2, and you could do 9 to the negative 2, but now I just don't have one negative exponent. I've got two things with negative exponents, right? So this is like a shortcut. If you see something in parentheses and it's in a fractional form and it's being raised to a negative power, what you do is you flip your fraction and your power becomes positive. Now we can look, and right here, if you have a fraction raised to a power, the top gets the power, the bottom one gets the power. Everything in the top gets the power, everything in the bottom gets the power. So this would be 9 gets the power, 1 gets the power. I can evaluate that, right? 9 squared, that's 9 times 9 is 81. 1 squared, that's just 1. We don't have to write that over 1 though, right? We can just do it that way right there. I just wanted y'all to see that. If you have it like this and it's raised to a negative, flip it, okay? I want to show you the quotient rule, and then I'm going to show you the quotient rule and 2 examples of the quotient rule. Same thing, one numerical, one with a variable. And then this is what we're going to do on Friday, like super fast as soon as class starts. This is a fractional form that has a negative. This has a negative. So I need to move this one to the bottom. I need to move this one to the top. That actually just ends up being the answer to this one, okay? But this one, do you see how it's a little bit more involved, right? I want to do this one for sure because it's towards the end of that homework for y'all. And then this one, this is got negatives in the top, negatives on the bottom, raised to a negative. So we're actually going to flip, then everything gets the signs, and then you're going to have power to a power, and then some things are going to flip. And then, I mean, it's everything all in one problem. So I want to make sure we get to that. That ends up being the final answer. For now, though, let's do this, and then we'll be done for today. Quotient rule. We use the power rule when things are multiplying, right? We're going to use the quotient rule when things are dividing. So in parentheses, with our fraction bar, in the numerator, I have something, A, raised to the nth power. In the denominator, I have the same base. I have the same kind of something. So I also have A. Now I'm going to raise this one to the nth power just to be very clear that they don't have to be the same exponent. They can be different. They usually always probably will be different most times, okay? If we have this, oh, you don't have to do the parentheses. I don't know why I did, just because it's in a fraction form. It's really just this, y'all. A to the m divided by a to the n. But most times with fractions, you might have parentheses. It's okay if you write them or if you don't. Whenever you divide like bases, you keep your base, you subtract your powers. So when you're multiplying, you keep and add. When you're dividing, you keep and subtract, okay? So really quick, what are my examples? Let's do one where it's just like a numerical value. Say our base is 2, and it's being raised to the 16th power. Now divide that by 2 to the 3rd power. And again, the problems are many of these in one problem. This is just real specific so you can understand the rule, right? Are those the same bases? Yeah, they're both 2's because I've got 2 to the something divided by 2 to the something. What you do is you keep your base, subtract your powers. What? Nope. Subtract your powers, right? 16 minus 3 is 13. Now this one real quick, and I'm going to say one word and give you all y'all's exams. Say we have x to the 9th divided by x squared. Are those the same bases? Right? My x's, those are the same bases. Usually after a while, I stop saying bases and I start saying like, are those the same variable, right? Because those are the same variable. And when you divide variables, what you do is you keep your variable and you subtract your exponents. So I would get x to the 7th. Does that make sense? Okay, technically that ends 12.1 and 12.2, except for like that really big ugly problem that I will do on Friday, and we'll do 12.3 and 12.4. So if you have an exam grade that you do not like, I need you to check your Dragon email, like immediately, like ASAP, okay? If you do not know how to check your Dragon email, that's probably a whole other problem in itself. Email me, tell me, hey, I don't have access to my email, and I will make sure you can get access so that you can read the email that I'm hoping helps a lot of people. Where are y'all's exams? Oh, boom, there they are. Oh, I wanted to say one thing. Let me cancel this. Y'all just don't hate me. I usually don't go over, so y'all